Hi, and welcome to another recording. So this is going to be quiz 3 recording, quiz 3 review. So this is a minor review. Again, this is always helpful to see prior to taking your quiz. Quiz 3 is in charge of sections 11.1 through 11.3. So in this chapter, we learn about probability, different types of probability. And we start with easy, and then we build on to harder questions. So the first question is asking you to find the probability given a spinner and landing on a red. So on a red, there's 2 reds out of how many? So the total probability is 1, 2, 3, 4, 5, 6, 7. There's a total of 7 outcomes, and there's 2 reds. So the probability of landing on a red is 2 out of 7. This is the probability. If you can break down the fraction, please do so. But this one, you can't reduce, so it's 2 out of 7. Now, find the probability. Two fair dies are roll. What is the probability of the sum of the roll of the dice is 8. So when we're dealing with the probability of rolling a dice, there's two dice. So the total of 2 dice is 36 outcomes. So that's the total. And how many sums can I make out of 8? So we have our options are 1 through 6. So how can I make a sum that will give me 8? Well, 2, 6, or 6, 2. I also can do 4, 4. I could do 5, 3. I could do 3, 5. What else could give me 8? Well, 1 and 7, but 7 is out. 2 and 6, that is 8. 3 and 5, 5 and 3. I could do, that's it, right? So it looks like 1, 2, 3, 4, 5 different options. So the total is 5 out of 36, because 5 of those options give me 36. This gives me 8, the 3 plus 5, the 5, the 3, the 4, the 4, the 2, the 6, and the 6 and the 2. They all give me a sum of 8. So the probability of landing a sum of the die to be 8 is 5 out of 36 outcomes. Okay. You can also look at the probability table, meaning you can create the product table for rolling a die. You should know how to do that already. And then you could just see the outcomes of the sum being 8. Okay, we did this in the past. All right, what if you have a bag that contains 13 balls, 1 through 13? So let's say you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. And they're looking for the probability of selecting an even number. So which ones are even numbers from here? So an even number is, it can be 1, 2, 3, 4, 5, or 6. 6 out of 13. So there is a probability, since there's 6 evens in 13 different outcomes, then you have 6 out of 13. Okay. So that's what you want to do. If I would ask for an odd, well, then you just count the odds depending on what they want. So for example, the next question we have for the following problem is, there's 3 fair coins that are tossed. Again, the first toss, the second toss, and then the third toss. We've done this in the past. We've seen that there is 8 different outcomes for this. We've seen this many times. So the total outcomes are 8. but we want exactly 2 heads. How do we find exactly 2 heads? Well, given that we have, so if we want exactly 2 heads, it's going to be head, head, tails. That's one option. Or tail, head, head. That gives me 2. You can also, so you have head, head, tails, you have tail, head, head, you have tail, head. Right? So if we count our outcomes, so we have head, 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 tail, head, tail, head. So we want exactly 2 heads. So we're looking at, oops, that gives me 3 heads. So we're looking at 1, 2, and 3 different options. So if we're looking for 3, exactly 2 heads, there's 3 out of 8. So this is our probability. Okay. Because we want exactly 2 heads. So here we have head, head. We have head, head, tail. We have tail, head, head, and we have head, tail, head. Those are the 3 only ones that we have. So you can look at that, looking at the tree diagram and listing all of the options. Okay. Number 5. What are the odds against? This is important. If you're looking at the ones against it, you first look at which numbers are less than 4. So you have the 2 and the 3, but you're looking at the ones against. So you're, which ones are against? 1, 2, 3, 4. So 4 against 2. You have 4 things against for having a number being less than 4. 4 is not less than 4. Okay. It's equal to 4, but it's not less than 4. So you have 4 against 2. Okay. And that's how you, because the 4, the 6, the 8, and the 10, those are 4 different outcomes versus the 2 that are less than 4. Okay. Number 6, find the empirical probability given this table. So this table, first grader, second grade, third grade, fourth grade, and then the types of drinks that they like. Some like soda, some like lemonade, and some like water. And they're asking us to find the probability that a random second grader, so we're looking at this column, prefers lemonade. So we look at this particular column because we're focused on, oops, second graders. And more especially, so the total number of second graders, and if you don't remember the empirical probability formula, so it's the probability of the event is the number of the event occurred over the total number of the experiment. So in this case, we're looking at prefers lemonade, a second grader. So that's 23. That's the event. And the total number is the sum of 21 plus 23 plus 12, the total number of our second graders, because that's the population we're focused on. So if we have, so we have 23 divided by, and then we go ahead and take our calculator, or we can do this easy sum. So we have 21 plus 23 plus 12, we get a total of 56. And then we divide it out. So 23 divided by 56. That gives us roughly 0.4107. And we want to have this as our answer. So make sure you divide it out. So 23 divided by 56, not the other way around. Okay. That is the empirical probability. So the event is the second grader, a second grader. Find the probability that a random second grader prefers a lemonade. So we know that 23 prefer lemonade out of how many second graders we have. And that's roughly 41.41. The next question is find the probability of a fair die is rolled. So the fair die, what is the probability of rolling a 1 or a 4? So whenever you have the probability of A or B, and these are called independent events, there's a formula. So the probability of a 1 times the probability of a 4. The probability of a 1, rolling a 1 is 1 out of 6 times 1 out of 6. So we get a probability of 1 over 36. And the probability of landing a 1, well, how many 1s are there that you can get from rolling a dice? Okay, and that looks like 1 out of 36. So we have of 2 independent events. However, here, if we go back to our formula,